Today we're talking about absolute value equations and inequalities. We have to solve the absolute value of x plus 5 equals 11. So we need x by itself, so what we have to do is subtract 5 from both sides. That means the absolute value of x is equal to 6. Now, when we have a variable inside the absolute values, we have two answers. X can be equal to 6 and x can be equal to negative 6. Why is this true? Well, we can find out by checking. We have the absolute value of x plus 5 equals 11, and we substitute x with 6. The absolute value of 6 is 6 plus 5 equals 11, and we can see that this is true. Now if we substitute x with negative 6, so the absolute value of negative 6 plus 5 equals 11. The absolute value of negative 6 is 6, plus 5 should equal 11, and we can see that 11 equals 11. So both of these answers make the equation true. If we have to solve the absolute value of 2 times p plus 5 equals 11, we have to begin by writing two separate equations. So we're going to write 2p plus 5 equals 11 and 2p plus 5 equals negative 11. We're going to solve each of these equations. Subtract 5 from one side, subtract 5 from the other, divide by 2, divide by 2. P can be equal to 3. We solve the next equation, minus 5, minus 5. 2p is equal to negative 16. Divide by 2, divide by 2. P is equal to negative 8. These are our two answers. If we check the absolute value of 2p plus 5 equals 11. If we substitute p, this would be 2 times 3 plus 5 equals 11. The absolute value of 6 plus 5 should equal 11. The absolute value of 11 equals 11, and this is true. If we check with negative 8, 2 times negative 8 plus 5 is 11. The absolute value of negative 16 plus 5 should equal 11. The absolute value of negative 11 is 11. The absolute value of 11 is 11. That's equal to 11. That means both of our answers are true. If we have to solve the absolute value of v minus 3 is greater than or equal to 4, because there's an expression inside the absolute value, we have to write these twice. So v minus 3 is greater than or equal to 4, or v minus 3 is less than or equal to negative 4. So what happened? I flipped the sign here. I flipped the sign and I added a negative. So we're writing it twice, except that one of them it's exactly the same, like we have here, and the other one we have to flip the sign and change to the opposite. Do you see that? After this, we would answer each of them. Plus 3, plus 3. B is greater than or equal to 7. Or, and I'm going to talk about this or right now, b minus 3 is less than or equal to negative 4, plus 3, plus 3, b is less than or equal to negative 1. How do I know this is an or? When the original equation has a greater than or greater than an equal sign, it will be or. When the original, not equation, inequality has a less than or less than and equal, it's an and. One more time. One more time. When the absolute value inequality has a greater than or greater than an equal sign, it will always be an or. When it has a less than or less than an equal, it will be an and. So in this case, it's an or. This means we can rewrite this as v is greater than or equal to 7 or v is less than or equal to -1. If we graph this, -1, 7, it will be a closed circle. This will be a closed circle. If we have to solve, the absolute value of w plus 2 is greater than 5. With this greater than, we know that our graph will be an or. What do we have to do next? Write it twice. So we write it straightforward as we have it. W plus 2 is greater than 5, or W plus 2 is less than -5. Remember that in this second one, we flip the sign and do the opposite of that last number. Can we solve each of these? -2, -2. W is greater than 3, or W is less than -7. Let's graph this. What should our graph look like? Anybody? Pointing out, very good. So -7, W is less than -7, and this should be an open circle. And W is greater than 3, open circle.